Hi all, very happy afternoon to each and every viewer who is waiting for the class or who is watching the class online right now. Very happy afternoon to each one of you. The most complex topic in permutation and combinations, that is de-arrangement. This is one topic where most of the students will blindly use the formulae without knowing the logic behind the formulae. Most of the teachers also will not discuss the proof behind this concept and varied problems where this concept can be used. Extremely tough topic in permutation and combination. I assure you that by the end of the class, these concept will be extremely clear to you. De-arrangement, complex topic made easy, right? So just watch the entire class. What I will do is, I will tell you the structure of the class, so that follow the same structure. At the end of the class, you will be extremely comfortable in de-arrangements. Kindly let me know if you are facing any audio issues. Is audio perfectly clear? Are we good to go? Are you facing any streaming issues? Are you facing any streaming issues? I will tell you the structure of the class. Are you facing any streaming issues? Kindly reply to the live chat, then we will begin the class. Very important class. Kindly let me know if you are facing any de-arrangement, one of the topics which most of the students as well as the teachers neglect this topic, but we will discuss this topic because good number of previous year examination questions comes from de-arrangement. Kindly reply in the live chat if you are facing any audio issues or streaming issues. If not, please reply with no. Please reply with no. Very important class. I want each and every viewer to have a dialogue based communication with me via live chat, so that I will come to know whether you have understood the concept or not. Yasmin says no issues. What about others? Kindly reply, sir. Once you all say no issues, then we are good to go. Communication with me via live chat. No audio issues. Every student kindly reply. I got a feedback saying that there is a double audio. I don't think there is a double audio, right? Communication with me via live chat. 1 minute, sir. So let me see what is the issue. Is it clear right now? Kindly, Vamshi says that there is a double audio issue. So I just switched off my laptop audio. I don't think that there should be an issue right now. Let us see. Is it clear right now? Kindly, Vamshi says that there is a double audio issue. So I just switched off my laptop audio. I don't think that there should be an issue right now. Let us see. Is it clear right now? She says that there is a double audio issue, so I just switched off my. I think it's coming. Are you getting any double audio issues? Just 1 minute, sir. Are you getting any double audio issue? Just give me 1 minute, sir. Once the now check it out once again. Are you facing any double audio issues right now? Let us, any audio issues right now?
Now check it out once again.
Any audio issues? Kindly reply. Babu says no issues. What about other students? What about other students? Everybody kindly reply, sir. I don't want any student to go through any of the technical issues when the class is on. Kindly acknowledge in the live chat before we start the class. Kindly acknowledge in the live chat if in case. So I think everybody is saying perfect. So let us start the class. Now, Praveen, door close say, nee mobile audio low bettu. Right. Now we will discuss dearrangement. Dearrangements. Extremely important topic. The structure of the class is, the structure of the class will be like this. First we will see what is the definition of a dearrangement. What is the definition of a dearrangement and some examples related to dearrangement. Some examples related to dearrangement. What is D of n notation? D of n notation and its proof. Dearrangement of n distinct things and its proof. And its proof. Then we will find out the values of d of 1, d of 2 and so on up to d of 5. Then we will solve some practice problems based on, practice problems based on dearrangement. This is the structure of the class. First we will see what is the definition of a dearrangement, what is some examples related to dearrangement, what is d of n and how to calculate d of n. There is a notation that is there. We will discuss the proof of that notation. Then we will find the value of d of 1, d of 2 till d of 5. You can go on and use the value, find the values for d of 6, d of 7. Some practice problems. Now, structure of the class is like this. All these 5 key points, one by one we will discuss. First key point, dearrangement. Dearrangement. In some textbooks, it is also called as the concept of mismatch. This is also called the concept of mismatch. What is this one? Suppose I took n distinct things. N distinct things are there. They have to be arranged in n places. They have to be arranged in n places. There are n distinct things. They have to be arranged in n places such that no thing occupy its original place. No thing occupy its original place. This is the definition of a dearrangement. Dearrangement. There are n distinct things are there. They have to be arranged in n places. For example, number 1 is arranged in first place. Number 2 is arranged in second place. Number 3 is arranged in third place. Number 4 is arranged in fourth place. Number 5 is arranged in fifth place. Suppose if I arrange like this, 5, 1, 4, 3, 2. 5 should be there in fifth place. It is not kept in its fifth place. 1 should be there in first place. It is not kept in first place. 4 should be kept in fourth place. It is not arranged in fourth place. Third should be kept in third place. It is not arranged in third place. Second should be kept in second place. It is not. This arrangement is called dearrangement or a mismatch arrangement. None of them is taking its original place. None of them is taking its original place. Suppose for example, there are 3 boys, B1, B2 and B3. They got 3 girlfriends, G1, G2 and G3. Right? No boy dances with his girlfriend. No boy dances with his girlfriend. This is another example of a D arrangement. B1 has to dance with G1. B1 and G1 are couple. B2 and G2 are couple. B3 and G3 are couple. No boy dances with his girlfriend. It is also an example of a D arrangement. There are three letters, L1, L2, L3. L1 should get into envelope 1. L2 should get into envelope 2. L3 should get into envelope 3. No letter gets into the right envelope. No letter gets into its right envelope. This is also an example of a D arrangement. D arrangement is simple language is none of the thing is there in its original position. Everything it is altered to a different position. None of them is arranged in its original position. These I hope it is clear. Mismatch means everything is mismatched. One should be there in first position, but it is not there in the first position. Two should be there in second position. It is not there in the second position. This is called the D arrangement. D arrangement. Arrangement is arranged properly. D arrangement is not arranged properly. Completely mismatch position. Completely mismatch position. I hope the definition it is clear. Most of the students what they will do is there is a formula for it. D of n is given by n factorial into 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. 3 factorial. 3 is an odd number before there is an minus. So and so on up to minus 1 power n divide into 1 by n factorial. They will by heart these formulae and they will substitute it. D of n is nothing but n factorial into 1 minus 1 factorial, 1 by 2 factorial and so on up to minus 1 power n into 1 by n factorial. Now what we'll do is, we have seen the definition of an D arrangement. We have seen the various examples of a D arrangement. We have seen the formula of a D arrangement. Now let us see the proof of these formulae. How these formulae came into picture. Right? Now let me take an NCERT example. A1, A2 and A3. A1, A2 and A3. These are three distinct things. These are three distinct things. This should be there in first place. This should be there in first place. A2 should be there in second place. A2 should be there in second place. A3 should be there in third place. This is the original arrangement. Right? So I want D of 3. What is D of 3? Number of ways of arranging. Listen carefully, sir. Once you understand, it's easy. Number of ways of arranging A1, A2, A3 such that none of them is in its position. None of them is in its original position. This is the definition of D of 3. None of them is in its original position. None of them is in its original position. Now listen carefully. Let us see the proof. Suppose A1, A2, A3. This is the first position. This is the second position. A2 should be in second position. A3 should be in third position. These are the exact positions. A1 first position, A2 second position, A3 third position. N of A. N of A is nothing but number of ways. Number of ways such that A1 is in its first position. If A1 is in its first position, we only first A1 it is in first position. That means A2 and A3 are not in its respective positions. Not in its respective position means A2 can go to third position, A3 can go to second position. How many ways are there? 2 factorial, which is nothing but A2 can get into third position and A3 can get into second position. I hope it is clear. N of A is the number of ways of arranging such that A1 is in its first position. n of b is the number of ways of arranging where a2 is in its original position, a2 is in its second position. If a2 is in its second position, a1 can get into third position and a3 can get into first position. Again 2 factorial. I hope it is clear. Similarly, n of c, number of ways of arranging such that a3 is in its third position. If a3 is in its third position, only a3 is in its third position. If a3 is in its third position, remaining 2, a1 is not in its first position, second position, a2 is in its first position. Two things, 2 positions, 2 factorial. I hope it is clear. Next one, n of a intersection b. A intersection b is number of ways of arranging such that a1 is in its first position and a2 is in its second position. a1 and a2 are in its right position. a1 is in first, a2 is in second. That means a3 will be in its third position. It is 1 factorial. n of b intersection c. b intersection c is number of ways in which a2 and a3 are in its positions. If a2 and a3 are in its positions, obviously a1 will be in its original position, which is 1 factorial. n of a intersection c is number of ways such that a1 and a3 are in its original position. If a1 is in first position, a3 is in third position, a2 has left got only 1 position, which is 1 factorial. Are you all with me? This is nothing but a2 is in its second position. If a2 and a3 on its original position, a1 is in its first position. Here it is nothing but a3 is in its third position. a3 is in its third position. Number of ways of arranging such that all the 3 are in its position. a1 is in its first position, a2 is in its second position, a3 is in its third position. There is only one way. a1 in 1, a2 in 2 and a3 in 3. I hope it is clear. n of a suggests that number of ways of arranging a1 only in first position. If a1 is in first position, a2, a3, 2 things, 2 positions, 2 factorial. Similarly, a2, a1, a3, 2 things, 2 position, 2 factorial. I hope it is clear. n of a, n of b, n of c. What do I require? I require such that a1 and a2 and a3 are not in its original position, are not in its original positions, are not in its original positions. Now what I will do is, I will use the concept of Venn diagram. This is the number of ways where a1 is in its first position. This is the number of ways in which a2 is in its second position. This is the number of ways in which a3 in its third position. This is nothing but the total number of ways. This is nothing but mu. 3 things, 3 positions. This is nothing but 3 factorial 6. What do I require? Number of ways in which a1 is not in its position, a2 is not in its position, a3 is not in its position. This dark shaded portion we require. Shaded portion, it is nothing but mu is nothing but n of a union b union c plus n of neither ab nor c. Neither ab nor c. Neither ab nor c. These only we require. These is nothing but n of neither ab nor c. Neither ab nor c. It is nothing but mu minus of n of a union b union c. A union b union c, it is nothing but, according to De Morgan's theorem, n of a plus n of b plus n of c minus of n of a intersection b minus of a intersection c minus of n of a intersection b intersection c plus n of a intersection b intersection c. I hope it is clear. This portion we require, the portion which is shaded. This is nothing but mu equivalent to n of a union b union c plus n of neither AB nor C. N of neither AB nor C, it is nothing but mu minus of n of A union B union C. Now we will write it here. N of neither A, B nor C. Listen carefully, sir. Once you understand it, it's very, very easy. It is nothing but mu minus of n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Three people can arrange among themselves in three positions in 3 factorial. N of A, I got 2 factorial. N of B, 2 factorial. N of C, 2 factorial. Minus of 1 factorial plus 1 factorial plus 1 factorial plus all the 3 are in its original position 1. These are nothing but 3 factorial. This can be written as 3 into 2 factorial. This can be written as 3 into 1 factorial plus 1. Are you all with me? Now if you see here, this can be written as 3 factorial minus, there are 3, n of A, n of B, n of C, selecting any one. A1 is in its original position, A2 is in its original position, A3 in its original position, remaining 2 factorial. A intersection B, 2 I am selecting, out of 3, select any 2, remaining it is 1 factorial plus 1. I hope it is clear. So this can be written as, now here, if I take 3 factorial common, this is nothing but 1 minus 3 into 2 factorial by 3 factorial. Minus into minus plus 3 into 1 factorial by 3 factorial. Minus into plus minus 1 by 3 factorial. Now if you see here, this is nothing but 3 factorial. 1 minus 6 by 6. It is again nothing but 1 by 1 factorial. 3 by 6, which is nothing but 2 factorial. This is nothing but minus 1 by 3 factorial. For 3 things, what I got? 3 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. Now it should be very, very easy for you. I hope this concept is clear. Simple application of Venn diagram can give a beautiful proof to this concept. For 3, what I got? 3 factorial into 1 minus 1 factorial, 1 by 2 factorial, 1 by 3 factorial. That means, let me write D of 3. How much we got? 3 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. Similarly, if it is 4, do the 4 set. Similarly, you will get 4 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. I hope it is clear. So what we got? D of n is nothing but 3 factorial minus of 3 into 2 factorial minus 3 into 3c1. It is 3c2 into 1 factorial and it is plus 1. If it is instead of 3, it is n factorial minus nc1. Right, remaining it is nothing but n minus 1 factorial. nc2, remaining it is nothing but n minus 2 factorial, and so on. So if I take n factorial common, this is nothing but n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial minus 1 power n into 1 by n factorial. I hope the de-arrangement proof is extremely clear to you. A very, very simple concept. 99% of the teachers don't teach the proof behind this concept. But if you forget the formula also, you can do it by using this way. I hope it is clear why d of 3 is 3 factorial into 1 minus 1 by 5 factorial. N of A, it is the number of ways where A1 is in its original position. N of B, number of ways in which A2 is in its original position. Number of ways in which A3 is in its original position. A and B, B and C, A and C. I want none of them should be in its original position, which is neither of A, B nor C. Neither of A, B nor C is mu minus of N of A union B union C. I hope the idea it is clear. So now we will write down D of N, it is nothing but N factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial minus 1 power n into 1 by n factorial. Suppose one question, examples. First question, there are 3 letters L1, L2 and L3. These letters should not go into the right envelope. No letter should get into the right envelope. If the question is there, no letter should get into right envelope. Right envelope. What will be the answer? Right envelope. This is nothing but D of 3. D of 3, it is nothing but 3 factorial into 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. 3 factorial, it is 6. 6 into 1 minus 1 by 1 plus 1 by 2 minus 1 by 6. 1 minus 1 cancel. This is nothing but 3 minus 2. This is nothing but 3 minus 2. I hope it is clear. No letter should get into the right envelope. Another example. Suppose if it is 4 letters are there. 4 letters should not get into their respective envelope. This is nothing but D of 4. 1 minus 1 factorial, it is 1. So this is nothing but 4 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. 24 into 1 by 2 minus 1 by 6 plus 1 by 24. So it is 12 minus 4 plus 1. Answer, it is 9. There are 9 ways are there where 4 letters cannot get into the 4 right envelopes. There are number of ways in which 3 letters do not get into their respective envelope. T of 3 value, it is nothing but 2. Now we will write this, it will be useful. N and D arrangement of N. N and D arrangement of N. If N is 1, so one letter is there, one envelope is there, right? Not going, it is 0. It is 2. D of 2 is there. L1, L2, E1, E2. L1 can get into E2, L2 can get into E1. D of 2, it is 1. D of 3, just now we got it as 1. D of 4, we got it as 9. D of 5, till here it is extremely important for your examination. D of 5 is 5 factorial. 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. These is nothing but cancel. 120 into 1 by 2 minus 1 by 6 plus 1 by 24 minus 1 by 120. These is nothing but 60 minus 20 plus 5 minus 1. D of 5 value, it is nothing but 44. Very, very important. D arrangement. N1 0, N2 1, N3 2, N4 9 and N5 44. I hope the idea it is clear, right? Now we will see. We have seen the definition, we have seen the examples, we have seen the proofs, and we have seen the values of D arrangement of 1, 2, 3, 4. Now let us take some practice problems. Practice problems. Let me take the first question. Practice problem. This is an original exam question. Most of the students thought that this question is difficult. Question is, in how many ways? In how many ways? How many ways can you form a dancing? Original exam question. In how many ways can you form a dancing couple? Dancing couple from 3 boys. From 3 boys and 3 girls. And 3 girls. such that no boy dances with his girlfriend. No boy dances with his girlfriend. That means if there are 3 boys, B1, B2, B3. If there are 3 girls, G1, G2, G3. B1 and G1 are one couple. B2 and G2 are one couple. B3 and G3 are one couple. This should not form. This is nothing but an example of a dearrangement of n distinct things. N is 3. D of 3 value, it is nothing but 2. D of 3 value, it is nothing but 2, which is nothing but 3 factorial into 1 by 2 factorial minus 1 by 3 factorial. 6 by 2, 3. 3 minus 1, which is nothing but 2. Just by looking at a question itself, you will get the answer. I hope this first example it is clear. Letter and envelope example should also be clear to you. Letter and envelope. Another exam question. In how many ways? In how many ways? In how many ways can I keep? In how many ways can I keep 7 letters in 3 into respective envelopes such that exactly 3, we will do a lot of questions, sir, such that exactly 3 get into the right envelope. Exactly 3 get into the right envelope. There are 7 letters are there. There are 7 envelopes are there. In how many ways can I keep 7 letters into respective envelopes such that exactly 3 get into the right envelope? When I say exactly 3 get into the right envelope, that means exactly 4 do not get into the right envelope. Exactly 4 do not get into the right envelope. If 4 letters do not get into the 4 envelopes, D is nothing but D of 4. D is nothing but D of 4. Out of 7, select any 3 which gets into the right envelope. 7C3 into D of 4. D of 4 value, it is nothing but 4 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. This is nothing but 24. 1 by 2 minus 1 by 6 plus 24. This is 12 minus 4 plus 1. This is nothing but 7C3 into 9. Out of 7, select any 3 which gets into the right envelope. Remaining 4 do not get into the right envelope. If 4 letters do not get into the 4 envelopes, it is nothing but 7C3 into D of 4. I hope the idea it is clear. 7C3 into D of 4. Next, there are set of questions that came, right? So this was from an exam things. Anil and his 4 friends. Anil and his 4 friends work in Hyderabad. Work in Hyderabad. During vacation, they want to go to their native place. During vacation, they want to go to their native place. They want to go to their native place. They want to go to their native place. Right? Now, first question. Only Anil reaches home. Only Anil reaches home. And other 4 do not reach home. Other 4 do not reach home. Right? They all started from Hyderabad during vacation. They want to go to their native place. Only Anil has reached his own home. Other people did not reach home. That means 1 is arranged properly. Remaining 4 friends did not reach their own home. That means they might have reached an other friend's home. There is nothing but remaining 4 friends. Remaining 4 friends do not get into their respective home. I hope it is clear. Do not get into their respective home. If they do not get into their respective home, this is nothing but D of 4. D of 4 value, it is nothing but 9. D of 4, the value, it is nothing but 9. I hope the idea it is clear. Anil only reached home. Remaining 4 friends did not reach their home. Maybe they went into their friend's home. They should reach their own home. They did not reach their home. That means other 4 people might have visited a wrong place. So 4 letters, 4 envelopes, such that no letter gets into the right envelope. D of 4, it is 9. Next one. At least 3 friends. At least 3 friends reach home. At least 3 friends reach home. This is another good question, sir. At least 3 friends reach home. This is nothing but exactly 3 friends reach home. Exactly 3 friends reach home. Next case is, are exactly 4 friends reach home, or exactly 5 friends reach home. 5 friends reach home. I hope it is clear. Minimum 3. So minimum 3 could be, total 5 people are there. Anil and his 4 friends. Minimum 3. It could be exact 3, exact 4, or exact 5. Now see here. If exactly 3 friends reach home, out of 5 select any 3 which will reach home. 2 people are not reaching home. So it is 5C3 into D of 2. Exactly 4 reached home. If there are 5 houses, 4 people reached their own home. Obviously, it is equivalent to. That means it is saying that 1 person did not reach his home. That is invalid. If 4 people are going to their 4 homes respectively, the last person should visit the remaining home, which is his home. So, exactly 4 reaching home, it is 0. Exactly 5 friends reach home. So L1 will get into E1, L2 will get into E2, L3 will get into E3. All of them reach their own home. There is one way. D of 2, it is nothing but 1. 5C3, it is nothing but 10. 10 plus 1, it is nothing but 11 ways. 10 plus 1, it is nothing but 11 ways. I hope you understood the concept of, right? At least 3 friends reach home. At least 3 friends reach home. Suppose if the question is, at least 3 friends do not reach home. At least 3 friends do not reach home. At least 3 friends do not reach home. At least 3 friends do not reach home is greater than or equivalent to 3 friends do not reach home. Greater than or equivalent to 3 friends do not reach home. This is nothing but 3 friends do not reach home. We do not know who are all that 3. Out of 5 select 3. Or 4 friends do not reach home. It is D of 4. We do not know who are all that 4. Out of 5 there could be 5 choices. 5 friends do not reach home. It is D of 5. So out of 5 select 5. I hope it is clear. So 5C3. 5C3 value it is 10. D of 3 it is nothing but 3 factorial into 1 by 2 factorial minus 1 by 3 factorial. 5C4. For D of 4 it is nothing but 4 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. 5C5 it is 9. D of 5 we got it as 44. This is nothing but 10 into. This is nothing but 6 by 2 3. 10 into 2. This is nothing but 5 into. I think D of 4 value it is 9. Let us check. 120 into 1 by 2 minus 1 by 6 plus 1 by 24 plus 44. This is 60. So sorry, D of 5 it is nothing. D of 4 is 44. D of 5 please determine 5 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. 120 into 1 by 2 minus 1 by 6 plus 1 by 24 minus 120. 60 minus 20. plus 5 minus 1. Oh, this is 44. What is this value? This is nothing but 5 into 4 factorial, it is 24. So these is nothing but 2 12s are 12 minus 4 plus 1. So answer is 20 plus 5 9s are 45 plus 44. Very, very easy question. 45 plus 44 is 89. 89 plus 20, 109. 3 friends do not reach home. 3 letters do not get into their right envelopes. D of 3. But we do not know which are all 3. Out of 5 it can be any 3. Out of 5 selecting any 3 will be 5C3. Greater than or equivalent to 3 friends. 4 friends do not reach home. 5C4. 5C5. D of 3 value it is 2. D of, if you know the values, the value answer will be very easy. D of 3 value will be 2. D of 4 value will be 9. D of 5 value will be 44. So answer is nothing but 1 into 44 plus 5 into 9 plus 10 into 2. I hope the idea it is clear. Next question. These are all easy questions if you know the logic. These are nothing but at least 2 friends do not reach home. At least 2 friends do not reach home. At least 2 friends do not reach home. These are nothing but 5C2 into D of 2. I hope it is clear. 2 friends do not reach home. At least 2. 5C3 into D of 3. 5C4 into D of 4. And 5C5 into D of 5. If you know the values, it will be very easy. D of 5C2, it is nothing but 10. D of 2, it is nothing but 2 factorial into 1 by 2 factorial, which is 1. 5C3, it is 10. D of 3, it is 2. 5C4, it is 5. D of 4 value, it is 9. 5C5, it is nothing but 1. D of 5 value, it is nothing but 44. Easy if you understand it. 10 plus 20 plus 45 plus 44. Answer is 30, 75. 75 plus 44. Answer is nothing but 119. I hope you got an idea of how to use D arrangement. What is the definition of D arrangement? No particular thing can take its original place. No particular thing can take its original place. Where all these questions can be formed? 3 boys, 3 girls. Right? No girl dances with her boyfriend. One example. 3 letters, 3 envelopes. None of the letter goes into the right envelope. Second example. Like that. 3 distinct things are there, 3 distinct positions are there, right? Suppose if the question is 1, 2, 3, 4, 5, if these numerical values are arranged in first position, second position, third, fourth, fifth, in how many ways, right? Only 2 positions are with the correct places, you can use it. How many ways? Whether minimum 3 positions are there. D of n, it is n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial and so on. Proof with respect to 3 things we have done it. Then we have extended it for D of 4, D of 5. Then we have extended it for D of n. D of 1, D of 2, D of 5. Like that values we have determined. We will read the question and go it step by step.